So apparently it's September now, and I think like most of you, time sort of stopped for me in March. So to me it says September 7th, but it feels like March 190th. And so I know what my September problem is. My September problem, which maybe I'm not even ready to think about, is how am I supposed to teach programming over the internet? So maybe it's better for all of us if we dial it back and think about a March problem. So, I mean, we've come a long way, I guess. Apparently, if we think back to March, there was no toilet paper in town for like a month and a half. That was annoying. But what some people may not have remembered is that you go to the store, and of course, it's in the news, there's no toilet paper available, but there was also no flour. Like, they were out of everything for a while, but they were out of flour for a long time. And I think it's because, from what I could tell, a lot of people said, okay, I guess I'm stuck at home for a while, and so I'm going to learn how to bake my own bread or something. And so they went to the store and they bought a bunch of flour. And I don't know, good luck to them. I hope they're doing well with that. I have a feeling that they just started buying bread again pretty quick after that. But I was annoyed because I wanted to buy flour and there was no flour in the store for like a month and a half. And what's weird about that is that I guess I knew how to make bread already, but a lot of these people that thought, okay, so, I can't go to the bakery, it's time to go learn how to make bread, they got home with their huge bag of flour, and they were sort of stuck, because how do you learn how to make bread? Well, you could look up a recipe, you could read a recipe that somebody else wrote that tells you what ingredients to combine. Okay, well, that helps a bit. You could watch a YouTube video of somebody else making bread. That sort of helps too. But really, you do those things, you mix the ingredients together, you try kneading it, and what you come up with maybe isn't so impressive at first. And the problem is, you can't learn to make bread over the internet, and you can't learn to make bread by watching somebody else do it, and you can't learn to make bread by reading about it. And I think the same is true about programming. And so the way I want to approach programming, the way I would approach it in any other year, is that the way to learn how to write code is to write code. If you want to learn how to make bread, you just have to make bread over and over again if you have to, until it works. And each time you do it, you figure out what went wrong and you fix it next time. The same is true with writing code. And it turns out that programming languages have a lot in common with human languages like English or Mandarin or French, which is that the only way to learn them and develop confidence is to use them. You can watch somebody else speaking a language, that certainly helps a bit. You can read about it, that helps a bit too. It maybe becomes useful to know about the structure of a language, to know what's a verb and what's a noun. But to a large extent, being told all the terminology, having it explained to you what verb conjugation is, isn't really helpful until you've actually had a chance to play with the language yourself. And that's the same, I think, with programming. And so the way I want to approach programming is the same I would approach, if I was qualified to do so, teaching you how to bake bread, or maybe teaching you how to drive. Now, some of you may have learned how to drive already, maybe most of you, and if you did, you probably spent most of your life riding around in cars with people until you were old enough to learn to drive, and then you learned to drive. And you didn't learn to drive by somebody showing you slides. You didn't learn to drive by reading a book about it or by somebody telling you all the rules. It's good to know that a stop sign means stop. It's good to know what you do if you and somebody else get to a four-way stop at the same time. But really, the only way you can learn to drive is by getting in the car and driving. But that puts us in a bit of a difficult situation. I think the same is true of programming. The only way to learn to write code is to do it. The problem is there's a pretty high startup cost. You have to know what's going on. And what you've been staring at on your screen for the last couple of minutes is probably pretty intimidating. So maybe you've been able to figure out that this here is code. Okay, and it doesn't seem to be doing very much, but how do we know what code does? We've never seen code before. And if my advice was get in the car and drive, you shouldn't just watch somebody else programming, that's not how you program, then how is this whole business going to work? Well, I would argue that, watching somebody else drive or going for a ride in somebody else's car can be sort of helpful. It can teach you what you can and can't do. But the only way to develop that confidence is to do it yourself. And so my hope, after the first couple of videos, but not for this one, after the first couple of videos, my hope is that you will be able to, if you want to, follow along. Listen to what I'm saying and then pause the video and go try it yourself. That is how you will learn it. You won't get much out of a course like this by just memorizing definitions. And you'll discover I personally sort of hate exam questions that tell people to recite a definition, because obviously I'm a computer scientist and that's what computers do. The goal of computer science in the context of a programming course, the goal of a computer scientist should be to learn how to do something, not just how to know things, because computers are pretty good at knowing things, and our job is to make the computers do something that's useful. Another thing we want to consider is that many of you, of course, are in the position of thinking, wow, I'm going into some engineering discipline, and I never realized they'd make me learn programming, and so I'll take the course, sure, I'll put up with you for 4 months, Bill, and then I'm out of here, and then I'm going to go on and do interesting things. And that's fine. I would say if you want to come up with a reason to be motivated in a course like this, if what I'm saying already isn't enough, then consider the fact that really the ultimate goal of programming, I mean, whether it's this or some other course, the ultimate goal of programming is to save people time. That's it. And you can use programming even in this setting, even in late September of 2020, you can use programming to save yourself time, to automate annoying things that you will have to do, maybe in your other courses, like having to manually input a bunch of things into complicated formulas for physics or math or something. You could write quick C programs by the end of September that could do that for you. That is the goal of programming, and that's the way I'm going to approach it. The goal of programming is to save people time. And if the goal of programming is to save people time, that should be the same goal that governs how we learn it. We shouldn't need to learn new techniques if we already know techniques that will work. And so in this course, I will try and hold as much as I can to that philosophy, which is we don't need to learn a new clever way of doing something if the existing boring way of doing it would actually be faster for us. Okay, so how do we get started? Well, I want to start before you get set up to write your own code, which will happen in the first week of labs, and you could even log into this platform that I'm using right now if you want to. Before we get started, maybe before you get in the car and start driving, it's useful to know what a car looks like. So we'll start there. And I want to go through the basic process that a programmer goes through to write a single, simple program and run it. So get to the point of being able to experiment with pieces of code. So the first thing we have to clarify is, what is code? I mean, that's sort of an obvious thing to need to talk about. And so, well, the answer in our course is this weird cryptic mess. Okay, I guess the next question is, why do we need to write code? Why does it look like this, and why do we have to write it? And the answer is pretty straightforward, which is that I want to speak English. And I guess all of you speak English, but you might want to speak some other human language as well. The computer, though, does not want to speak English. And even if the computer could speak English, because we've got some pretty advanced systems for natural language processing these days, even if the computer could speak English, we probably wouldn't want to trust the computer to understand English perfectly in all cases. If I describe a complex, safety-critical computer system, so maybe an autopilot for an airplane, if I describe that in English, there's a chance that the computer may not interpret the English correctly. There's a lot of reading between the lines and context that's important to understanding English. We don't want the computer to need to do that. Okay, so the computer can't speak our language. So, I mean, this is us up here, humans. Okay, so why don't we just speak the computer's language? I don't know. That's like, from movies, that's ones and zeros, apparently. That's binary. Well, okay, so a modern computer processor, you could argue that it speaks something called machine code. And yes, you could think of that as binary. Usually machine code corresponds to very simple step-by-step instructions that do the most basic things, like add the number 5 to the number 6. Or move this value from one place in the computer's memory to another. And that's really tedious. We want to think about problems at a high level. And so what happened over time, over the years, is that we have humans and we have computers and they have to work together. And the languages they can speak lie on this sort of a spectrum, from what humans like, that's English, down to what computers like, which I guess is machine code. And we should also keep in mind that different computers might speak different types of machine code. So even if I did want to learn this, it wouldn't be worth it, because I go buy a new computer, it could speak different machine code. I don't want to worry about that. Instead, maybe we could come up with a compromise. Maybe we can make up some language that a computer can sort of understand, that's precise and scientific and rigorous, but that also maybe humans could read. And by the end of this course, the stuff over on the left here, this whole thing looks pretty intimidating, and that's fair enough. By the end of this course, we will be able to understand, interpret, and read code like this. We may not like it. I don't know if I can convince you to like doing this by the end of December, but we will all be able to do it. So what we have in this course is an example of one of these compromises, a programming language. And you know, the language we're going to learn, because you're all along the engineering stream, the language we're going to learn is a compromise, but it's pretty close to the machine side of things. I'm going to put it down here. And it's the language called C. And this is no end of trouble for me. The language's name is just one letter long. It's C. And the reason is because it's based on a language called B. That's the best I can come up with. It was designed in the early 1970s. Things were different back then, apparently. If you go on into software engineering or computer science, or actually other courses in electrical and computer engineering or mechanical engineering or biomedical or civil, you're going to end up programming no matter what it is. You will learn there are lots of other languages, and some of them are closer to English than machine code. So an example, computer science students, people majoring in computer science, might learn as their first language a language called Python. Python's great. I use Python all the time. It's lots of fun. It's a bit closer to English. It's a bit easier for humans to read, but because it's further away from what the machine understands, it tends to be a bit slower, and it tends to give the programmer less absolute control over what the machine does. If you're working in an engineering context, you want that low-level absolute control, and so you want to end up down with languages like C. There are also languages you might hear about. Maybe I'll put this. There's a language called Java that's still pretty popular. There, of course, is a language called C++. Most of you will go on to learn at least one of Python, Java, or C++ in the far future. Not in this course. We're going to spend the entire semester talking about C. What we'll discover is that there are some people out there that have programmed before, and they go around bragging about, oh, I know like 10 different programming languages. Yeah, it would be really exciting if you meet somebody that knows like 10 different human languages. That is pretty impressive. Programming languages, not so much. I like to think about it, if learning to program is like learning to drive, then learning a programming language is like learning to drive a new kind of car. If you learn to drive one kind of car, it's not too difficult to hop into a different one. It's certainly true that there are some vehicles that are harder to drive than others. And so certainly my 2006 Suzuki Swift, which is still miraculously running pretty well in 2020, is sort of like Python. It's pretty easy. I just hop in and drive, and then I just cross my fingers that it's going to make it to my destination. A language like C is a bit harder. It's like learning to drive on an 18-wheeler. But the advantage of learning C as your first language is if you learn to drive on an 18-wheeler, then you're going to be able to hop in just about any vehicle on the planet and figure it out. So we shouldn't think about different programming languages as being too challenging and having to start again from scratch to learn our second one. It's about whether you can program or not. And then beyond that, it's about picking up the fundamentals of some new language. So we're going to spend the entire semester just talking about this one language, and its name is C, and we're going to learn to both love and hate it. One of the reasons why it's a great language, it's my favorite language, the language I think everybody should learn as their first language, I guess, which is why I teach this course. The reason I think it's great is that it is very logical. It doesn't have very many arbitrary rules because languages are designed by people, and people sometimes make up arbitrary rules. C doesn't have very many of them. C is a very logical language. If you want to know how to do something and you know how to do a few other things, you can often sort of deduce what you're supposed to do based on what you already know. The reason why you'll grow to hate C is that C doesn't have very many rules, but they're pretty strict rules, and it's got a pretty steep learning curve. It's not very easy to get to know it. Python has a lot of arbitrary rules, but Python's pretty friendly and easy to get to know. So we'll discover, and if previous years are any guide, I'd say the first few weeks of the course will be a bit of a trial by fire for people, just because, not because the material is necessarily very hard, but because there's a lot of a new setting you all have to get used to. And it's certainly, the course doesn't necessarily become dead easy eventually, but after a certain point it levels off in terms of the number of new things you have to absorb. So that's all fine. Let's talk about that starting in the week of the 15th. For today, let's instead just talk about running one basic program. And so let's get rid of this. So what I have here is the traditional very first program that somebody writes. In any language, the tradition is your very first program, whether it's the first time you've ever programmed or you've been programming for 20 years. The very first program you write should be a program that does nothing but prints an output to the user, and the output should be the words "Hello World." And so this is, you could argue, the most basic C program that does anything. And so it prints we can see, I've been waving my hands at this for a few minutes saying this is code. You might see, well, there are the words hello world. And certainly there's a bunch of weird incantations that we don't understand quite yet, like what this means. I guess there's my name in there. That's sort of flattering. Whatever return 0 is, the use of these curly brackets that many of you may have never actually needed before in your life. But there's the important part. And the goal of this video is to show, first off, how we do this, and second, how easy it is to experiment, and maybe proving the point over time that experimenting with this code is the best way to learn from it. So the first question is, if C is a compromise between English and the computer, how do we get the computer to run it? Well, usually we would follow a procedure sort of like this. We write our code, and I'm going to call this editing our code because usually we don't write code in one sitting. And if you think that's a good idea, you're going to need to kick that habit. The best way to write code is to write a small amount at a time and to test it at every step. Because at each step, that means you can verify that what you just did makes sense. So I'm going to call the first step edit. Maybe we start by writing the initial bit of our code, but we edit, and then we have to provide our code to an external program that takes it and converts it into machine code. We don't want to think about machine code ourselves. We want to take our C code and convert it to machine code with some automation. And so I'm going to call this compiling it. And the program that we use for that purpose is typically called a compiler. I'm going to, maybe over the semester, learn how to draw boxes better too. Okay, so once I've compiled my code, if my code was not valid, so if C is just like any other language, you have to form complete sentences if you want people to understand you. If your code is not valid, the compiler will complain. It'll say, I don't know what to do with this. And then you have to go back and edit the code and fix the problem. If the code is valid, then you can run the code. And so the typical next stage of our pipeline is run. So I run the code, and then in the process of running it, you might call the next step testing it, or maybe we could call that debugging it. So code has bugs if it has some error that we didn't intend, and debugging it is the process of getting rid of that. And we test and debug it, and then if there are any problems, we might have to go back and edit our code again. And this goes around in a circle. And I would argue the best technique to develop is you might, in each edit step, add one line of code. And then you compile, run, and test, and make sure that one line of code worked great. And then you go and you add the next one. And the reason that's great is it lets us be very scientific. If I edit it, I add one line, and it breaks, then where was the problem? Well, it was probably in that one line that I just added. Okay, so I have some code here. And I've stored it in a file called helloworld.c, and the first set of labs will give you more practice on what is this business with all these files, why are they called .c, and how do we edit, compile, run, test, and debug. So the point of this video is just to give you a high-level overview. So I have the code, it's in a file, and I'm hoping the code is valid, but I don't know if the code is correct until after I have subjected it to this compile process. So how do I do that? Well, down here I have a command window. Now, the environment I'm working in today is our course's virtual lab, which all of you can access through a browser. And it gives you access to basically a virtual lab machine to work on, because we have no computer lab. Well, I mean, we have one, but you can't go there. So this gives you access to a virtual machine that's all yours, that you can use from anywhere on Earth. But your own computer actually has this feature too. If you're on Mac, it's called Terminal. If you're on Windows, it might be called Command Prompt. If you use a Linux machine, it could be called, well, probably Terminal or Console or something. And this lets me run low-level commands directly with the computer, issue commands directly through the operating system. The command I want to give today is I would like to take my file helloworld.c and I want to attempt to compile it, to turn it into a finished program in machine code. Now, I've actually prepared the command already, and I mean, if you weren't panicking already, here's this. There's quite a bit to unpack here. So what I have is I am asking the computer to use my C compiler. So, of course, there are lots of programming languages you can use in life, and C is only one of them, and so there is a different compiler for every language. There are lots of different C compilers. Talking about a C compiler is like talking about a word processor. So you could use Microsoft Word, you could use LibreOffice, you could use whatever Google Docs calls its Word documents, I don't know. Just like with a C compiler, we're using a specific C compiler called GCC. I don't know if GCC is the very best C compiler in the world, but it's the one that we have on our virtual lab, so that's the one we're going to use. And I have generally had good results with it in the past. So I'm telling the computer, run the command GCC. Now all this weird stuff here is telling the compiler what you really want. So I want to compile my C code using the 2011 C standard. So STD equals C11. The shorthand C11 means the 2011 standard. This is telling it to turn on all possible warnings. So the compiler, if it notices something that doesn't look right, will give you a warning about it, which is great. It's annoying to have to deal with critical feedback, I guess, but if the compiler if it flags something for you, that's a good sign and you can go fix it. You might not have noticed that. So -w all is telling the compiler to give you any warning it can come up with. Turn on all possible warnings. This is saying, when my program is compiled, where do you want me to put it? So -o means where do I put the output of the compiler? The compiler's output is a finished program. I'm just going to call it hello world. And then finally, at the very end, what is the name of the file I want to compile today? And of course, it is my hello world.c, which I have up here. You can see it over in the file browser as well. So I'll try this. I'll press enter, and then I'll hope the compiler doesn't complain. And apparently nothing happened. Well, that's weird. So the compiler is like your colleague. It's got a job to do, and it doesn't really have time for small talk. If the compiler can do everything correctly, it doesn't say anything. So in this case, no news is good news. If there was a problem, the compiler would complain. But if it doesn't complain, you can assume everything worked. And if you go looking in the file browser that I have over here, you can see, hey, there's hello world. Not hello world.c, just hello world. That's actually my finished program, and I can now run it. So how do I run it? Now, detailed instructions and a whole lab will be spent talking about this. So don't be overwhelmed if I'm going through things quickly. The idea is to give an overview of that whole pipeline that I've written up there. So I run this with I write // and then I give the name of the program. The name is just hello world. And then I press enter. And there it is. The output of the program just shows up in my terminal. Okay, hello world. So I've run my first C program. And before I finish this video and move on to the next one, I want to do one quick experiment. So what you ought to do once you get everything set up and you can compile and run code yourself, first test out that you can compile and run a hello world program of your own. But then see how much you can change. Given that you currently know nothing about how to write C code, even if you know nothing, I'll bet if you're scientific about it, you could do some experiments. The biggest experiment to try is, could you make the program print out something else besides just the text hello world? I'll bet that's something that's pretty attainable, so try that. What I want to do at the very end, though, is I want to show what happens if the compiler complains. So you're noticing, okay, this is all cryptic. I have no idea what any of this means. I guess I better not touch anything because I might break something. Because you're afraid of breaking stuff because, you know, most of your life that's sort of been a bad idea. In programming, breaking stuff is great. It doesn't feel right at first, but it's so right. So let's try this. Why do we end each line in a semicolon? I don't even know if I can answer that question. But certainly you might be asking, okay, I don't even like semicolons in English. Why am I using them in programming? So let's just try getting rid of one. So I got rid of a semicolon. I'm going to save the file. And a common mistake, I make this all the time, is make sure you always save your file after you change it. And then I'm going to go and try compiling it again. Every time I change my code, I have to compile the code again. If I want to do this, I could type the command myself, but I can actually use the up and down arrows here just to recall previous commands that I ran. So I'm going to run this, press enter. And here you can see the compiler complained. And if the compiler complains, it'll tell you error. And then it says, I expected to see a semicolon before I got to the word return. So what it means is somewhere before the word return, like up here, it was missing a semicolon. You might notice the compiler doesn't have time for small talk. It didn't tell you why. It just said, give me a semicolon. Okay, so I'll put the semicolon back in. And we'll save the file, and we'll try it again. Now, okay, yeah, it feels sort of bad to hurt the compiler's feelings like this. Remember that the compiler is sort of helping us. If we keep compiling our code as we go, we can catch our errors early and we can fix them. Because we remember, clearly the only thing I've done recently is remove that semicolon. So if the compiler complains, I'll bet it was that semicolon that was the problem. So I try it again, and here it does work. And then I'll run it again just to make sure it still prints the right result. Okay, so now we have edited, compiled, and run, and actually gone back and re-edited our very first C program for our obligatory hello world. In the next video, I'm actually going to talk a bit, I'm going to try and explain some more of these arbitrary incantations. By the end of September, we'll actually know what all this stuff means, and even this thing here. What I want to explain later today, well, maybe it's today for you, I don't know, but later today for me is what this stuff at the top is, because clearly there's something special about this if I can put my own name in my program and I can have a date there. So come and take a look at that.